Hey there everybody, Mr. Dickin here. In this video we're going to talk about another function operation, and that is going to be the composition of functions. Now, composition doesn't mean what are functions made of. It's not like a chemistry lesson here. Composition of functions is another operation, and that's where we're basically plugging in one function into another function. So it'll make sense when we see them. But first, let's just kind of recap what we know about function operations. So far, we've talked about the main four: addition, subtraction, multiplication, division. So here I've got f plus g of 0, right? So f plus g of 0. So if I wanted to find f of 0 and g of 0, well, f of 0 is going to be 4, g of 0 is going to be 5. So if I'm going to add those together, 4 plus 5, well, that would just give me 9. Next, if I did g divided by f of negative 1, g divided by f of negative 1, well, so that's giving me 2 and 0. It says g is on top, so 0 divided by 2, well, that's just 0. F minus g of negative 3. So it's f minus g, so I'm going to take 3 minus negative 1 to get 4. And then lastly, fg, or f times g, of 2. So negative 6 times 3, right, f times g, is going to give me negative 18. Hopefully, those weren't too terribly taxing on us when we did those previously. So now let's get into the new stuff. Composition. What composition means is you're going to see a whole bunch of functions, and I have a number example here, kind of plugged into one another. So there are going to be a lot of embedded parentheses, and that's okay. That's perfectly fine. So to get into composition, let's first talk about how we might tackle something that looks like this. Anytime you have multiple sets of parentheses embedded within one another, you always want to work from the inside outward. So the first thing I want to do is take care of the innermost set of parentheses, and that was 4. Everything else can come down, remaining the exact same. So all I did is just simplify that one step. Well, now I'm going to deal with the now most inner set of parentheses. We've got 2 minus 4 plus 5. So 2 minus 4 is negative 2 plus 5, we're at positive 3. So that whole thing is going to turn into a positive 3. So now I've got 3 times 3. Oh, well, that simplified pretty nicely. That's just 9. So anytime we are evaluating this, you're going to want to work from the inside out. A big pitfall some folks will run into is they'll see something like this 3 is attached to parentheses, and they'll want to distribute, and you're going to get yourself in a whole load of trouble if you try distributing into an expression that has embedded parentheses. All right, so composition of functions. The symbol of composition is this little hollow circle. So anytime you see what looks like fog or golf, that's really f of g, and this would be g of f of x. Me personally, I'm a huge fan of rewriting these things with this notation. The order of the letters will still say the same, right? F of g, so f of g of x. Down here, g of f of x, g of f of x. And the reason I like to do that is it's a lot easier, I find, for me to actually go through and figure out, okay, what am I plugging in to what? So let's take a look down here. Part A and part B. Let me go ahead and draw like a little dividing line so I don't run into space issues. Part A is saying f of g of x. So part A is saying f of g of x. I'm going to rewrite that. So f of, and then g of x. And again, this just helps me kind of visualize it. And what that's going to have me do is it's going to take the g function which in this case is x squared plus 6, I'm going to take the g function, and that's going to get plugged in to the f function for x. All right, so this whole g function is going to get thrown in there for x. Algebraically, what does that look like? Well, the f of x function is saying you take 3 times whatever our input is, and you take away 4. In this case, our input was the g function, and that was it x squared plus 6? Yeah. X squared plus 6. So I've done my composition. I've plugged one function into the other. I plugged my g function into the f function. And now all that's left to do is just do some distribution. So 3x squared and 16, right? If I distribute that 3 in there, minus 4. So I would get 3x squared plus 14. Well, let's do the same thing now. Let's do f of g of x plus 1. F of g of x plus 1. This one's actually going to be a little bit more challenging for us. So we have f of g of x plus 1. Well, remember what I said earlier, right? We always want to work from the inside out. So I'm actually going to take care of this g of x plus 1 business first, and then we'll plug that into the f function. So g of x plus 1, that means I'm going to take the g function, and in place of x right here, in place of x, I'm going to replace that with an x plus 1 in parentheses. So g of x plus 1 is really going to be x plus 1 squared plus 6. And with x plus 1 squared, we're really doing x plus 1 times another x plus 1. It's not just going to be x squared plus 1 and call it a day. That's not how it works. So after I do some distribution, simplification, all of that, we're going to get x squared plus 2x plus 7. That's what this will simplify out to. And that is what's going to get plugged in for the f function. So now I have to figure out, okay, what was the f function asking? Well, the f function was 3x plus 4. 3 times my input, sorry, not plus 4, minus 4. So 3 times something minus 4. So the f function states 3 times something minus 4. That something just so happens to be x squared plus 2x plus 7. Well, let's do our distribution, make it look nice and pretty. We're going to get 3x squared plus 6x. Let's see, 3 times 7 is 21, minus 4 is 17, positive 17. Cool. That one was kind of involved, huh? All right, now let's work backwards. Let's plug the g function into the f function. So for part B, we're going to take the f function, which is 3x minus 4, and we're going to plug that in for x on the g function. So f is getting plugged in for x. Okay, well, when I do this, I'm going to first rewrite it. So g of f of x, and I know f of x was 3x minus 4, and that's getting plugged into my g function. So the f function was 3x minus 4, and that will have to get squared, and then we're going to take away 6, or sorry, add 6. Remember, 3x minus 4 quantity squared, that's going to be 3x, whoops, wrong tool. That's going to be 3x minus 4 times another 3x minus 4. That's a horrendous x. I'm sorry about that, folks. Which would be 9x squared let's see, negative 12x minus 24x plus 16 if I did that distribution. Then we have to add 6 at the end, so that would add to the 16 there, 22. So 9x squared minus 24x plus 22. That was disgusting. All right, what if we have a plain old number, g of f of 4? Well, this is actually going to be the easiest scenario. So if you ever see a plain old number as your input, that means your answer should be a plain old number. If you ever see that, it is time to rejoice, okay? So let's rewrite this first. G of f of 4. Man, writing with a stylus is not fun, people, I tell you. All right, so f of 4. Well, if I were to plug 4 in to my f function right here, 3 times 4 minus 4, right? F of 4, if I plugged in 4. 3 times 4 is 12, minus 4 is 8. So this is really just 8. So now I need to figure out what is g of 8. So I'm going to go to my g function, and instead of x, I'm going to plug in 8. So 8 squared plus 6. Well, 8 squared is 64, add 6 to that, and we get 72. Excellent. Okay. These examples are going to be the exact same. What I'm going to have you do is just go ahead and pause the video real quick, write these down, jot these down if you feel you need extra practice. But these will all be provided to you with the solutions on the online PDF. So again, same exact process as what we just did, just different functions. All right, let's go on to graphs. So this is where some people kind of get in trouble keeping things straight. And I think the best way to do this is if you can color code it, but if not, try to write things kind of spaced out and not condensed, and rewrite things so that you can really figure out what it is you're looking for. So I'm first going to rewrite this as f of g of negative 3. So I need to figure out what is g of negative 3. So to do that, I'm going to go to my graph. This is the g function right here. And when x is negative 3, that function value is negative 1. So g of negative 3 is really negative 1. So this is negative 1. I need to figure out what is f of negative 1. Well, f of negative 1, I'm going to go to my f function, this function right here, and if x is negative 1, my f function value is positive 1. So this whole thing simplifies out to positive 1. Now if we flip-flop those and did g of f, we might find that things could be different. So g of f of negative 3. I'm going to work from the inside out. Okay, so I need to work from the inside out. I need to figure out f of negative 3. I need to figure that out first. So let's take a look at the graph. I'm looking at the f function. When x is negative 3, my f value is 1. So this is really 1. And I need to figure out g of 1. What is that equal to? Well, g of 1, looking at the g function, would be, let's see, x is 1. The g function down here is negative 5. So g of 1 is going to be negative 5. All right, f of g of negative 1. All right, let's see. I need to figure out g of negative 1 first. So the g function, if x is negative 1, I get negative 3. And I need to plug that into the f function. So negative 3 going into for the f function. Negative 3, I'll get 1 for that. G of f of negative 2. So first, what is f of negative 2? That would be 0. And now I need to find g of 0, which would be negative 4. So those last two, you'll notice I was able to do without actually writing things out. Right? So once you get in the swing of kind of what's going on with composition, if you have a graph or a table, it's not too terribly difficult to follow along mentally as you go. All right. Now let's see, speaking of tables, what would happen if we did a table version? So first one, f of g of negative 3. So that's f of g of negative 3. I need to first figure out what is g of negative 3. Well, that would be right here, negative 1. So I need to figure out what is f of negative 1. So now I'm going to negative 1, and I'm looking at the f function, and that is 2. Next one for f of g of 0. F of g of 0. First, I need to figure out what is g of 0. Oops, this does not want to erase. So g of 0 is going to be 5. And now I need to find f of 5, which would also be 0. Well, that's a coincidence. Next, g of f of negative 1. G of f of negative 1. Work from the inside out. F of negative 1 is 2. So now I need to figure out g of 2, which would be 3. And lastly, g of f of 5. First, we need to figure out what is f of 5. So 5, f function is 0, and that gets plugged into the g function. So at 0, the g value is 5. All right, cool. That is it. And that is all for composition. You guys will have some practice opportunities on your assignments, which today is yet another Math Excel. So it'll be able to tell you right away if you're doing it right or wrong. If at any point you have a question, you know the drill, people, please let me know. Send me an email, do something. And I'll do my best to make sure that you get squared away. As always, folks, good luck, have fun, be safe, roll Tide.